Good morning, everyone. Again, today in this session, we will start with some of the other models creations of this machine wise assembly. As in the previous session, we have already created the body of this vise. We will go through the part drawings and see what is next. The as per this schedule, movable jaw made up of cast iron. It is part number two, and here you can see onto the screen here there is a three views of this component have been given. This is the front view, and this is right side view which is projected on the left side of this component, and this one which is top of here, it is bottom view of this component. So what is the raw material size here? This is 100 at this position, and this is 50, and then height will be, here he has mentioned 45 on this edge. From this it is 25, so you got the maximum size. Now you start your modeling creation of this component. First I will save the model by giving the properties, names, everything. This is movable jaw, and the document number is 2, and I will save it as 002 in the folder. The material here is cast iron. Okay, in the front view we will just create a block of 50 by 45 plus 25, this is 70. Take XZ plane itself as a front view perpendicular plane, and then use this as the bottom reference. From here height I will draw 70, and then I will extract this edge, offset it by 25 on either side. Now I will close this to create a block. Excuse me. Okay, now you just create by using symmetry 100 on side view, it is the width is 100. Okay, now it looks something like this block. Now start removing the material wherever it is not required. Here at the mid portion it is maintained as 40, and on either side up to 45 there is no material. So I will use this YZ plane as my plane, sketching plane. Draw a simple block here, make it as 20, and from the bottom edge I will maintain 45, though the area within this profile will be removed. It is symmetrical, so you use mirror option. In one go you can remove the material. Select both these profiles and select symmetry. That material is 50 mm. Now you can see this part has shaped up. Now keep it in the front view. and look for the drawing where other side materials have been gone here. Here you see there is no material over here, no material over here. Just create those blocks by seeing the dimensions. I will use XZ plane only. I will create one simple block here, and I will see the dimension from here to here. This face is 5 mm, and I just and this edge, bottom edge, is 3 mm away from this. Just 3 mm. This inside material we have to remove it, and then one more block you keep over here itself. uh, on this side, in the rear side, it is 45 plus 10, that is 55. So on the bottom it is 55, and then this edge is from this edge it is 35. Just from here to here you maintain 35. Okay. Mm, Now go back to 3D environment. Now use cutout option. Select both these planes. Use symmetry, and distance is 100. Okay, add it and see this. Uh, Now look for other operations that are needed to finish this part. There are holes here. Again, M6 threaded screws up for deep 10, and 13 is the hole depth. Their locations are given here. So first we will drill the holes. Uh, Take on this face, holes are given. Uh, Select this as the drilling face. So this is a choose threaded option and use 6 dia only. M6. The threaded portion is 10 mm, and hole depth is 13 mm. Use V bottom shape, and locate this first instance, and then by tracing this center you place one more pattern here, and then look for this dimension. From the bottom edge it is 15.5 and 60 mm apart. So from bottom edge I am restricting it to 15.5, and from the center line I will constrain it by 30. Now from here to this hole I will restrict it 60 as per the drawing. Now go back and see your preview. In front you keep it the model, and zoom it if you want to see the wireframe entities your hole has drilled in this way. Okay, and then again go back to the part drawing. There is a threaded hole here at the bottom side. From this bottom edge it is 27 mm, and then square threaded of 20 mm diameter hole is being introduced here. Just again you go to hole option, select this face, threaded and use 20 here. You use TR 20 into 2 for square thread, and this up to hole extent, because throughout the material this hole is been drilled. And for the location of the center, use this bottom edge reference. From here it is 27 given in the drawing. Go back and give the direction the hole has been drilled. Okay, and now look for other holes. There are some other holes here, threaded holes, which are given here with the same size and depth, and location is 24 mm apart. At the middle of this, you select the bottom face, and now I will click the hole icon and select the bottom face. They are threaded holes again, M6 dia, metric threads, finite extent 10 mm, threaded length, and hole depth is again 13 mm. We bottom, keep this one pattern here and another pattern here exactly at the middle. Now constrain it by 24 by 212, and then constrain it this hole. You should identify the center of this hole. I will just use another icon over here. I will translate it by center by 24. I will just copy this by center, and then move copy option is there here. Move copy, and 24 I will use. Okay. There are several ways to do if you find difficulty in using one command. So I just translated it. So go back to return command and see, you can see the front view in wireframe mode, and just the holes have been drilled. Okay, and now look for the other commands, and there are radiuses chamfers have been left here, and nothing much. And there is R3 and R10. Just give 3 mm radius, then here it is mentioned as 10. So I think this is finished. No more operations are left. Just glance anything is left over. Okay, I think this is fine. So you just hide your planes. bring it, I'll save it before closing your part. And if you want to uh, change the color and save it. Okay, this was a very quick creation, as it was very small. Operations were very less compared to the first part, and in this session only we will uh, just continue the creating. The other parts are very simple, I guess. Jaw grip is something like a plate here, a plate with some countersink holes. It is of 100 by 28 mm. So here itself you close this and open one more part, save, summary, jaw grip, project is 3, so save it as 3. Material for this is cast steel, cast steel. Okay, and just here this is a front view and side view. Just I will take a XZ plane here itself, and I will take this bottom line symmetric plane as the reference, and also extract this edge. So total is 100, and this is 28. Make a profile by trimming this. Just make a symmetry, and what is the thickness, and this is here in this view he has given 8 mm. Hide this, and now look for the countersunk hole details. This is countersunk dia, and shank dia is 6.3. Just it is 12.5 mm away from bottom edge, and then 60 mm apart from the center. So go for hole icon, select this face itself. Now choose countersunk option here, and diameter is given is 6.3, 6.3, and he has given 12 dia, and the angle countersunk angle is 90. And then through all option you make it, just click on here and one more here, and from bottom the center is it is 12.5 mm away, 12.5, and then from this you constrain it 30, 60, and then now. So knurling is he has given knurling details here for the jaw grip. It is the software has limitation, and the groove making and all, and those options have been not there in this. So we will finish this part we require a grip, and they are all surface finishing operations. This grooving, having a knurling on the to the surface. So these in many other advanced softwares these are available. Okay, right now we require this geometry. So save this. We'll change the color and save it. Okay, now next part you see it is a screw M6. Uh, the fourth part here it is given a screw. The details have been given. It is a 12 dia of 16 length. Uh, mention here screw M6 and then project. This is fourth part. Save it. And what is the material here? It is ferrous. So AP-410. Okay, you can create any plane you take as your wish. I will take a YZ plane and create. Let us see. Control dia is the outer dia, and uh, create the material by protrusion. This length is been given 16. Now I will hide this sketch, and I will take a XZ plane to remove the material. I will just draw outer profile, and I will extract this. This diameter is M6, so I will just offset it by 3 mm, and then he has given 3 mm depth here for the head thickness. From this line you just draw a 90 degree 90 by 2, that is 45 degree. Arrest it, lock it by the giving dimension. Now you can change this angle. Okay, now you just trim all these lines to get your shape required to revolve. So this is it, and revolve this using revolve cutout. Give 360 degree. Now hide your sketch. Now look for, there is a slot 1.6 mm width and 1.9 mm deep. So just create a slot, a rectangular slot here, and this is 1.6 by 2.8 and 1.6, and from here depth he has mentioned 1.9. Take a cutout option, make a symmetry. just 14 or 12 you give the depth distance. You will see this, and you can give a chamfer over here, a small 0.5, since the diameter is very small. And then you have a thread. This is M6 thread up to the whole extent. You can. So now this, I think this is enough for this screw. Okay, now save it, and look at the material schedule. What is there? A screw rod. Again, it is made up of ferrous, and screw rod is here, the fifth part. It is also cylindrical part of maximum dia 32, and then length is 40 plus 250, that is 290. First you create this um, stock size. I will close this. I will create a new part for this screw rod. This name of this is screw rod, and project is 5. So 305, and then material is again ferrous 410W. So take any plane, as I mentioned. The maximum diameter is 32, and quickly come back, add the material, use this symmetry option, and then 290 is the length. I will give 290, and now hide this. Now by creating the circles you go on removing the material. It is I have used that option here. From starting from this end, leave this from this face. You start from here. There is a M10 diameter is there. So from this take this end as your sketching plane, draw a 10 mm dia circle, and see the depth, how much it is. From here it is 22. Just use a cutout icon and use side step, give the outer direction, give 22. Okay, now you are here at this face. There is a 12 mm dia of 18 mm depth. Step is there. Again you pick this, hide this sketch, pick this face. There is draw a 12 dia circle, and then remove it by using this side step outside direction. 18 mm is the depth. Okay, next you use there is a 20 mm diameter is maintained throughout this. I think um, 18 plus 22 is 40. 40 and 40, 80, 80, 250 minus 80, this 20 dia is maintained. So select this, hide this sketch, select this face, and draw a 20 mm circle on this plane. Now select the cutout option, and then side step. You see this, this is 40 250 minus 80. 250 minus 80. I think we have gone wrong somewhere. To 170 and 250 minus 40. I think this. You go to the specification tree and just select here, and this is 2 250 minus 40. That is 40, and here it is 20. uh, Already I have gone 40, 250 minus 40. So select this, edit definition, 250 minus 40. Okay, hide this, and there is a chamfer over here. Give 1 mm chamfer. This is threaded portion. We just make it M10, and this is also a threaded one, square thread. But even if you give the thread will not be seen, only in drawing you will come to know that. Here 20 into 2 finite extent. He has given 170 as the threading length. So I think the major shape has come now, and now you have to have this uh, you have to have some drill holes here. Since it is cylindrical part, you just in front view select ZX plane. I will draw a center line here, and the diameter shown is 10, and from the this bottom edge it is 20. So give this with the use of cutout. You just 33 I will take, and the hole has been drilled here. Hide this. Now take on 4 sides these holes are there. If you look at this top view, mm, again it is a 10 dia, and the same distance 20. Use cutout again, use symmetry, and Okay, the operations are over now. Here he has mentioned radius 3. I'll give the radius here. So hide all the reference planes and save this isometric. Hit it. I'll save. Okay. So this is over, and now what is left next? So washer is there, a simple part we'll create in this session only. I will close this and I will create one more part here. Summary. This is washer, washer. It is 6006 and material is also a ferrous 410. So sixth one is 32 dia and 10.5 dia hole is there with 3 mm thickness. Just take XY plane and create 32 dia of circle. Go back and then use symmetry 3 mm thickness. Hide your sketch and use the whole command. Uh, how much? 10.5. It is a simple hole through wall. Keep it at the center. So hide all your reference plane while save it. Save this. Okay, now the next part is a nut. Seventh part. Here details have been given. Both are similar nuts, only the width is differing here. Here it is 8, it is 5, and one side it is flat and one side chamfer circle is made. He has given the external diameter, so no need to approximate it. 18.72 we will take and quickly draw this, quickly create the model. Memory nut 7. 007 and the material is again ferrous 0W. So I will use draw the outer dia, that is 18.72, and quickly draw the hexagon shape here, and one side I will maintain this as 60 degree, and then using this mirror option, here mirror option is there, and trim this quickly and join these endpoints. Okay, now go back and add the material. What is the depth? Depth is 8 mm. Give symmetry, 8 mm. Okay, and what is the hole diameter? M10. So go to hole option and zoom it. It is threaded M10 two hole extent through wall. Just keep it at the intersection, and that's it. And now approximately you draw the chamfer circle here. To create this chamfer, you need to have this line. .30 and extract this axis, and now go back and we use revolve cutout and select this inclined line, and then select this axis, give the direction outside, give angle 360. The chamfer is made. It is one-sided, I think, in the drawing. If you see the other side are not there, just save it, hide all these and save it. Okay, the next item is also similar, only the width remains 5 mm. So what we do is we will save it as 008. It has become a replica of that. And then what is the attribute? That only lock nut he has mentioned. Go to file properties. Here you just add lock nut, and project will be 8. Material is same, dimensions are same, only width is changing. So delete this cutout chamfer circle. Hole remains same, only right click on this protrusion, edit definition. Here you click on this 8, just say 5 mm, and to create the chamfer circle you just show your reference planes, fit it, and you can have a chamfer circle for this nut. And just extract an edge, with revolve cutout, choose this section, choose the axis, give 360 angle. Okay, now hide all the entities. Now hide all reference planes, save this part. Okay, now what are left? Clamping plate is remained, ninth one. I think this one, a simple plate with two countersunk holes. We will quickly create that and end the session. Later on in the next session we will start the assembling. I will just create this part, clamping plate, and this is ninth part, 009. The material is again ferrous, Fe410W. Okay, uh, first it is a simple part, 50 by 50 square with 8 mm thickness. Twenty-five, 50, 25, 50. Come out of this and create use symmetry, 8 mm thickness. Hide this sketch, and now look for these are 24 mm, and then uh, there are these countersink holes, 6.3 and 12 dia countersink kept at the center, 25 and 24. Okay, we will go to sketch hole icon, and then choose here the countersink. It is 6.3 and countersink dia is 12, and this is 90. Through all option you take. However, it is at the center. You make sure that this is 25, and the only thing you have to mention here is all, and from this hole to this center it is 24. Okay, you can see here the holes have been perfectly drilled. Okay, now I will save this model. I will save. I will save. Okay, so I think we have created all 9 parts. Uh, some were very simple, and body 1 and 2 required much time. Okay, but practicing, if you practice it, it will take very less time. So uh, in the next session we will assemble this, and we'll take assembly drawings in the next session. Okay, then see you in the next session. Until then, you keep on practicing using our part drawings, and with the use of solid edge software. Okay, see you.